let's think back to our testing. And as you can tell, I've now run out of batteries. But fortunately, I have multiple batteries for this camera. A little foresight of my summer session. So we will pop in a new battery and be right back. On track. All right. So let's think about sorting. Because our next class, we're going to be talking about sorting. And we're actually probably going to get into this a little bit at the end of this class. We talked about sorting tuples. And the thing I want to point out is that when you have a tuple with A1, B1, C1, D1, however many terms we have, and A2, B2, C2, D2, however many terms we have, and however many terms we have, and we do a sort, what we do, and this was brought out in your homework, is we sort based on this value, right? So if we're sorting lowest to highest, right, smallest to biggest, if A1 is smaller than A2, this would be the order. If we end up with a tie, right, we maintain these guys in the order they were, but any ties are broken by moving down this column, and any ties in the first two columns are taken care of in the next column, and so on. So if we want to get the two smallest algorithms, and this is the two smallest values, and maybe this is conceptually a little simpler to understand, right? What happens if we just take L, take the original list L and use it to create a list of tuples where the first entry is the value, first entry in the tuple, or first element in the tuple, element in the tuple is the value, and the second is the index. Sort the tuples. And return the index of the first two elements. Right? So if we sorted all of our tuples, and this is value index, as long as the values are distinct, what we're going to do is we're going to have this will be 0, this will be 1, this will be the index of 0, and this will be the index of 1, based on our current data sets, right? Whatever the data was, it would show up. It doesn't have to be 0 and 1. But based on our current data set, it would be like that. And conceptually, this is a very simple algorithm to do, right? So we can come up in here, and having done this one, we can now very quickly go through. And by the way, it was pointed out the first time I did this that there are other ways to generate lists of tuples. And yes, I understand that, but remember we are looking down here on the, our reason for doing this is exposition. So we want something that is the simplest thing to understand so that we can walk you through and make sure you understand everything that's going on. But this is pretty easy. We can say for index in, we need L1. So we need to have a list, and this list is going to be our list of tuples. We can say for index in range length of L. And now every time through this, what we want to do is we want to append to L1 a tuple where the first element of the tuple is the value, so L sub index, and the second value is the index, right? This is going to give us our indices. And then all we have to do after that is we just sort it. Right, we just do a simple L1.sort, right? So we'll sort our tuple list. And then all we need to do is return L1, right? Our smallest value is going to be in L1, 0, 1. That'll be the first tuple and the index field in the first tuple. And the second value is going to be L1, right? The second tuple at index 1. And again, the second element is the index, right? And if we do this, hopefully these will both give us the same answers, and we can start looking at, right? Okay, so 77, 71, so we can look at values sub 77. And we can look at values sub 71. And those are our two smallest values, so everything looks like it's working good. All right, so that's good. So now we have two implementations. And now we want to kind of look at these. Well, we already analyzed this one. So let's analyze this second one. That's a constant time, right? It doesn't take us really any special time. The time required to make a list isn't dependent upon the input size. This is an empty list. This is, again, our order of n, right? We're walking through every element. So that's an order of n. And now we come to this sort. And we'll talk about this a little bit more on Thursday this week. But I'm going to tell you right now that this is something called order of n log n. Okay, so our best sorts are generally around order of n log n. So what does that mean? Well, it's not n squared, so that's good, right? But it is more than linear, right? It's slower to do this than it is to do this. And then this, again, is an order of a constant time operation. So we have order of n plus order of n log n. This is bigger than this, so we throw this out, and this is an order of n log n algorithm. Okay? So let's see. So that's an analytic look at what we do. You look at every line and you see, how long is it going to take. Nested loops, you have an order of n on the inside, order of n on the outside. Nested, you multiply. Sequential, you add. All right. So now we've seen something from an analytical standpoint, a mathematical standpoint. Let's kind of look at the timing. And we tried running this with 100, and it didn't really give us good answers, right? It gave us 0. Let's try 1,000. Okay, so 1,000, they're pretty much equal. Let's run it at 10,000. Okay, now we're starting to see something, right? 10,000. This takes about 3 thousandths of a second, and this takes about 11 thousandths of a second. So we're starting to get to the point where we're starting to see a difference. And they started out equal, right? They started out at 0. But now as we start increasing our values, what we're going to find is that, in general, 100,000. The second one is going to get slower much faster. And they should still both be giving us the correct answer. We can look at values sub 32712 and values sub 84985, right? They're still giving us the right values. Let's run it for 1,000,000. 0.64 seconds, 2.8 seconds. So what you can see is that this one isn't getting horribly slow as we go up, but it's getting slower a lot faster than this one. And if we were to plot these out and do a good job of it, what we'll find is that minus the noise of my system, other processes running on my system, this is going to give you essentially a line, and this is going to give you something that curves up a little faster than a line. Not a lot faster. It's not going to be quadratic, but a little faster. All right.